It's interesting to be at a conference that has the word lock-in in the subtitle, and I happen to think that what I wanted to talk about was lock-in. I also thought, given the previous presentation, maybe I should sort of do like a live demo of all 50 open source projects in Netflix's GitHub repo, but I think I'll spare you that one. Okay, so who here doesn't like lock-in? Okay, so show of hands. Okay. So who of you are married? And we can obviously look you up on Ashley Madison if necessary to see whether you liked being married. But so lock-in is sort of good sometimes and bad sometimes. So let's try and understand it. And one of the ways, this is like a really gross generalization, but ITOps people try to avoid lock-in. Do you agree with that? Generally, it's sort of that's the mentality. And developers pick the best of breed option and don't really care about lock-in. Yeah. So there's an element here where there's sort of a tribal difference between the way people think about this. So that's how we now have developers versus operations. How do we deal with that? Well, let's go to DevOps, right? That's how we deal with any conflict between developers and operations. And let's go see what John Willis has to say about it, because one of the gurus of DevOps, and he always goes back to Deming. And there's 14 points, and let's pull it out. So you can go, I'm not going to play you the video, but it's a five-minute video. So, go John Willis, invoking the spirit of Bocciagaloop here. What would Deming say? Well, this is what Deming said. End the practice of awarding business on the basis of price tag. Instead, minimize total cost. Move toward a single supplier for any one item on a long-term relationship of loyalty and trust. That sounds like lock-in to me. That sounds like the developer idea. Not the, hey, I don't like lock-in, I want to get out of it. But that sounds like people deciding to get married. Right? And in fact, this is also a pretty good description of the Netflix to AWS relationship over quite a long time period. Netflix saw a value in making AWS successful so that AWS would always be big enough to run Netflix, and there were times when it was kind of a bit tight. So it's important that your suppliers are successful if you depend on them, right? So that's the mutual relationship. A lot of the sort of, the entire Japanese industrial sort of system is set up around these kinds of relationships. So that's all fine, but the problem is it ends up looking like this. And it ends up as a dysfunctional relationship based on exploitation and abuse. So how do we get to that, right? So that's kind of the problem. And that's why the operations people kind of go, yeah, but we set up this long-term trusting relationship, and then we ended up getting, the sales rep turns up and says, this year, you're going to give me $5 million, and we'll come back again next year, and you can give me $6 million, and it just keeps cranking up because you're completely locked into some huge enterprise thing that you can't extricate yourself from. So that's the problem. And so how are we going to deal with it, sort of escaping from this? And one of the points that I think is this is kind of something I finally realized after looking at this for a long time, is that this really comes down to the difference between organizations that work in terms of projects versus products. Just to look at the Netflix approach to this, it's a product-based company. Every team, every engineer is invested in the long-term ownership of a piece of code, a product, a service. This is the microservices architecture emerges from this. But if you continuously are updating and owning this thing and you're on call when it breaks, then you're not really, you're locked in now, but you're continuously updating it. You keep relocking into the latest best of breed. So it's an evolving system. The problem with most enterprises is they have a project. Hey, for the next year, this group of people are going to be upgrading SAP, right? And at the end of that year, you better be finished because we've got to throw it all the wall to operations, and then that team will scatter to the winds, and they'll go and work on a bunch of other things. So you do that, different sizes of projects, but that project-based mentality, basically, to break that next lock-in is another project, and it's a lot of work, and there isn't that ownership. So the difference really here is that the project-based approach a lot of enterprises are based on, that mentality tends to create lock-in. It creates legacy systems which the operations people have to deal with. Whereas if you integrate operations and development into one group where the operators are developing and the developers are operating, then you end up with something that's continuously evolving, and it helps you continuously break out of this. So if you look at that evolution, there's a number of different ways that systems evolve. One of them is technology refresh, right? There's just a better way of doing it. Solid-state disks are suddenly viable, or they start to get cheaper and cheaper, and you go, okay, I have to get my spinning rust, and I have to replace it with solid-state disk. That causes a big disruption, and maybe the lock-in from one vendor moves to another vendor. The move to open source is another great way of breaking lock-in, and the barrier here is low because it's free. Well, at least to start with. You can download it, and you can start playing with it. You don't have to go and spend $1 million and get a contract before you can start playing with it, right? So that ability to come in, and this is one of the ways that Linux appeared, and one of the ways Linux appeared in enterprise is people were running it at home. They solved problems with it at work because there was no barrier to them doing it. So open source takes a lot of friction out of this evolution. And then the other one is that you're seeing a lot of on-prem services where the incumbent is, you go and install this thing and hand tend it on a bunch of servers in your data center, being replaced by a SaaS-based application that people can sign up to, and the sales rep can sign up to Salesforce.com or Sales Manager or whatever. There's no developer involved in that process. You're in there configuring with a tool that solves a problem instead of going and arguing with IT about how to get your Siebel thing installed or whatever it was. Right. So this is the evolution. And the nice thing now is that the best of breed services, the best stuff you can possibly buy, is open source, and it's as a service. The on-prem things have too few customers, and they're evolving too slowly, and they don't. Once you get a big ecosystem around a piece of software, whether it's OpenStack or whether it's a SaaS product or whether it's a database, that product ends up being better than the things that you can buy that are the old style, built inside an enterprise, and we will sort of deliver it to you later on a platter. Like, we made this thing, we spent years building it, and you go, yeah, but I can get this open source thing, and it's actually better, and it's evolving better. So there is actually now less inherent lock-in in the world we're in now, which is largely as a service and open source, than there ever was in the sort of the legacy infrastructure. If you look around your data centers, you see all of these things that have accumulated over the last couple of decades. Those are the things you're locked into. Once you get into open source and web services, it's easier to move anyway. So let's sort of try and get a taxonomy. People talk about lock-in, but it's a fuzzy term. So I'm going to go through, I think, around 10 different types of lock-in that I thought of. And you probably think of some more, but let's just go through these. First one is business level lock-in. This is the hardest one to escape. And what I mean by that is things like legal lock-in. Right? You have compliance. You've got laws that say you cannot do anything other than this. Like if the law says these machines have to be, this data has to live in this country because the jurisdiction, then you're locked into whatever you can do in that country, right? That kind of thing. Financial lock-in. I've spent all my entire budget for the next 3 years was spent in advance on one vendor. I have no money left, right? I just get to use this thing for the next 3 years. So that's sort of financial lock-in. And that's sort of related effectively to you can get contractual lock-in. Sometimes you see startups saying, I'm going to take an investment from this vendor here, and that's cool because now I'm associated with this vendor and I get a bit ahead. And then all the competitors with that vendor won't work with them, right? You're contractually locked in, or you can't work with them as maybe a term of the contract, but it's basically you've got to deal with one vendor, you can't go somewhere else. So these ones, this is not a technology lock-in, it's a business problem, and you just have to try and avoid getting into these, or you have to figure out how to extract yourself eventually. Then there's technology lock-ins, which given a bit of time and work, it's possible to escape from them. And one of those, let's see, implementation. The interface is the same, but the implementation's different. So it's kind of annoying because you think it's going to work, but it doesn't. Maybe the bugs are different or whatever. So you have to kind of add stuff that shouldn't be there in your code in order to try and work around different behaviors and different things. And then you get proximity, where this thing has to be right next to this thing. Like typically your database client, your database servers, they're talking JDBC or something, and they expect to be very, very close, millisecond apart or something like that, and otherwise they stop working. And then topology lock-in, a bit more subtle, but if you look at sort of the way that Cassandra is typically run on AWS, it's on 3 zones. It's just 3 different data centers, and you say, well, okay, run it somewhere else, and go, well, I only have 2 data centers or only have 1. Well, okay, where do I don't have the right architecture. I need to always have 3 independent places to put my 3 replicas, right? So that's a topology-related lock-in. Over the last year or so, we saw Google really shift from a master-slave dual zone model to a 3-zone model, partly for this reason. They needed to match more closely the topologies that AWS was doing. And if you're doing, one of the areas I'm interested in OpenStack is how to federate multiple OpenStack clusters together, because you've got your cluster going here, but I want to have multiple clusters in different data centers, and I want to be able to provision across them. And I've got to, how do you federate the control planes? It's a particularly interesting area. So there's a few things there. With some work, you can work around them. And there are some that really are fairly easy types of lock-in. Like, if there's different interfaces, but they're just arbitrarily different, and they give you the same results, then you can easily add a layer over the top, which just says, if it's this one, use this one, use this, but it's the same behavior. Things like give me a virtual machine. I don't really care whose API it is for doing it. You can have a semantically equivalent thing that says, give me a machine, and you can put it in underneath. Things like in Stratius, we're trying to sort of build that layer. Then there's web services lock-ins. So the interface is very specific, but because it's a web service as opposed to a local connection, you have an HTTP request that's separately authenticated, and you can run it from your laptop, you can run it from a different cloud, you can run it from your data center. So web services are a little different. You're not actually locked in. They typically are more latency tolerant, and they allow remote access. So now you can take, I heard of one company who had said, well, we had 100K of free capacity on one cloud vendor, but our software that's managing that is running on a different cloud vendor, and we're just like, using it across here because there's this free capacity, right? So you can do things like this where if you want to take the most expensive part of something and move it somewhere else, moving from on-prem to public cloud or back and forth, you don't have to take, all of the services don't have to move. You can still access them remotely. So that's there's some latency issues, maybe a bit of bandwidth, but generally speaking, you're not really locked in the same way. Then there's sort of query syntax. Well, you've got the same basic structure, but your Postgres and your MySQL are slightly different, but you've got the same table structure. You can kind of tweak it slightly to get through that. And then data gravity. You've just got terabytes of data here. We had a big argument once on Twitter about people saying, yeah, but people only have really crappy bandwidth into their data centers, and they're trying to migrate to cloud. And I said, well, you should just get a 10 gig line into your data center as part of the cloud transition. You should be able to sort of move data reasonably quickly. And eventually the argument came down to something along the lines of, I think my final words were, if you've superglued something to the floor, then don't complain about gravity, right? You're being willfully difficult. It's possible to buy bandwidth, it doesn't cost that much, and you just have to deal with it as part of if you're really trying to build a hybrid application, don't run it over a piece of wet string and a couple of tin cans, right, to make it work. So it's possible to move enormous amounts of data around. And one of the nice things about this is that the public cloud side already has ridiculous amounts of bandwidth. You just need to provide enough bandwidth on the private cloud side. So let's talk briefly about what happens when you built an application that's cloud native and you built it out of microservices. You're building something that's inherently more portable. So I'm going to try and I had a progressive version of this, but anyway, I'll try and talk my way through this. You've got something. The typical thing really here is I have an application. I want the application to be able to run on-prem and in the cloud, right? And I want to be able to migrate it either way. I want to be able to run some capacity here, some capacity there, and I want to do the minimum changes. And that's kind of the application development sort of approach here. So let's say that I've got some Docker containers that contain my code, right? That's relatively straightforward. With a bit of testing and some care, you can build a container that will work identically on both sides, right? Then you've got to route traffic to it, so you're going to need a DNS provider. And if you're trying to automate API-based updates to your DNS provider, most DNS providers are designed for somebody who just got a ticket filed on them to type something into the config window. When you start trying to use the APIs, you find the APIs are very broken and don't work well. One of the interesting differences here is Route 53, which is you can do very complex things and it works, right? So having a dynamically provisionable DNS layer is actually important, and people need to pay more attention to that. But then you're routing traffic, and you can go to an ELB on Amazon or Nginx or whatever on your on-prem side. So that gets you the traffic routing. And then underneath that, you want some message queues. You could use Kinesis or Rabbit or whatever. You want to do some analytics, so you have a Hadoop cluster or Redshift. And it sort of doesn't really matter to the application. You can be feeding either one. Underneath, you could be using MariaDB, because that's MySQL compatible, or Aurora, which is MySQL compatible, right? You should be portable across both of those. And then S3 or Ceph. And then in the middle here, I've shown, let's say you just want to do use an Amazon feature that doesn't exist, like SNS or pick your favorite one. You can just access it remotely. So you can access it from both sides. So your notification system can be on one side, or you could have some service that only exists on your private cloud, so maybe some secure key stores or something like that, and you can remote access them too. So you're not really tied in as long as you have a web service-based access. And then the final thing I showed on here was this getting around this data gravity thing. If you do something like Cassandra, which runs on both sides, you can be continuously replicating data back and forth. So I think that there's ways around, in the modern world where we're building these applications, I think there are ways around most of the types of lock-in, the technology lock-in. So just watch out for those business lock-in. You're careful where you signed your contracts. That's basically what I want to talk about. Okay. I have a few minutes for Q&A, or I'll be around for the rest of the day. And just like a word from my sponsors, I work for Battery Ventures now. These are the companies that, in my field that I play around with. So if you want to talk about any of them, happy to discuss them too. Okay. Any questions?
We can take a question.
Take a question if anyone's got one. I have 3 minutes left, according to this, but I think we were running late, so we could do a catch-up. Okay. Alex.
So with OpenStack, what are some of the tight spots that you're seeing where there's this potential for it, or is it free of it?
I think so. One of the sort of OpenStack itself, I think the community of OpenStack is sort of it spends too much time thinking about how to build OpenStack and not enough time about how to build applications on top of it. I've always been a cloud architect of the type who's trying to build applications that run on cloud. So I'm particularly interested in the maturity of the higher level APIs, the developer experience on OpenStack. And I think that that's where most investment's needed. The downward facing APIs for managing elements in a data center, that side is where most of the sort of investment's gone over the years. And there's a lot of problems to solve there. But I think that once you've got a rich upwards facing API, I think there's some good opportunities. I think for example, Kubernetes is potentially a good play here. You've got Kubernetes on OpenStack, you've got Kubernetes on anywhere else you want it, and your developers can be operating at that level. So I think that makes sense as kind of up-leveling the way the developer experience, basically.
Adrian, I know you're no longer at Netflix, but can you comment on how the open source projects that Netflix has put out there for other people to use and whether those frameworks have proved to be useful?
Well, I left Netflix a year and a half ago, and they are still open sourcing things, which is good. I think there's quite a few useful tools there. I guess James is still around here, but the Pivotal guys, the Spring Boot, Spring Cloud people have actually taken a whole lot of the Netflix OSS tooling and built it into their systems so that you can actually consume it more easily. And one of the nice things there is that the Netflix engineers said, actually, that makes our life easy. They started consuming the work that Spring Cloud did and actually contributing it back. So by putting stuff out there, they got a better version and an easier to use version and have started consuming it. So it's feeding back on itself. The ecosystems, it's one of those things, everyone kind of, this is this nonlinear thing. When you try and create an ecosystem, you think, why is it taking so long? And then eventually it takes off rapidly, right? So there's this sort of nonlinear exponential thing where it's got a much more presence now than it had. The other issue really with Netflix OSS is that it's really designed to run on AWS circa 2010, maybe 2010, 2011. It doesn't use a lot of the more recent features, and they kind of have to either reboot it to use the more recent features and rip some things out. But what I've also noticed that OpenStack is kind of around 2010 as well, 2010, 2011, in terms of where it is versus AWS. So it's actually probably coming into alignment now that more of the Netflix tooling is actually more usable on AWS. Yeah?
Thanks for being here. Final follow-up question. As it relates to that developer experience, is that something that the community here can really focus on, or should that be an aligned project that integrates but doesn't have the same team trying to tackle the same and get into that expansive issue?
Yeah, I think it's been for a long time, over the 5 years of the project, it's been very much focused on the operational problems, right? Now I think it is changing, and there is more focus on the developer experience and the high-level problems. So but I think it needs to be within the OpenStack community. You've got to have a common experience, and you've got to have it be part of the base standard distributions, right? So that's the way I think it makes sense to do it in-house. It's just, okay, we've got this working, now how are you going to use it, right? It took longer than I think everyone thought to get it really to the point where it's working well, and now, so like the northbound APIs or whatever you want is an area. But I think, I'm seeing, like I said, Kubernetes is a good example, I think, of a powerful API that people can use. Makes sense to sort of base off of that. Basically, container running, it really comes down to I can run your containers too, right? So that's whatever that looks like. And then how do you build containers that are reasonably portable? Right, so and the point really is if you're depending upon some web service APIs, your containers can kind of run anywhere because the APIs are remotely accessible. So it's a way of decoupling it. You want to avoid direct access APIs, like you're talking on this port to this service that has to be right next to you. Try and avoid those and up-level it a bit. Okay, I think I'm out of time.
Fortunately, asking a question of you is like starting a search on Wikipedia where one link leads to another. So thank you very much. That was great. Thanks, Adrian.